Alright, here are solutions for perfect problem 3 for Math 251. In this one, I think I know there's two problems. In the first one, you're given the graph of a function and asked to sketch the graph of the derivative and of the second derivative. So what you need to know is that the graph of the derivative, the height of that thing you're going to draw, represents the slope of the tangent line to this curve at any given point. So pick any point you want, like a point right here. If you were to draw the tangent line to the curve at that point, it would look more or less like that. If you were to estimate the slope of that line, I don't know, how much do you go up every time you go over 1? I don't know, 4, 5, 6, whatever the hell you estimate that to be, is the height that you want the thing that you're going to draw to be at this x coordinate. So that's essentially what we're going to do all throughout this graph. A good place to start is by focusing on all the zeros of the derivative. So my derivative is going to have a height of 0 anywhere the slope of the tangent line to this curve is 0. Well, the slope being 0 means that you have a horizontal line. And the only places I would end up with a horizontal line are right up in here. So this x coordinate looks like right here. If I were to draw a tangent line, it would be horizontal. So that x coordinate right here and right there. So this thing that I'm going to draw better go through these 4 green dots. And what does it do around those dots? Well, I'm going to start out way the hell up here. Why way up here? Because if you were to draw a tangent line anywhere along this region to this graph, that line would have a very high positive slope. In other words, my graph right here is increasing and doing so pretty quickly. So that means the height of this thing that I'm going to draw should be pretty high up. It should be something like that. And then it goes through that point. And note that after it gets past that point, it's down here negative because the slope of the tangent line anywhere in here would be negative. Right? This line is going down, this line's going down, and it looks like they start going down faster and faster until it gets somewhere in here. So because it's going faster and faster, this height should be more and more negative until it gets somewhere in here. And then it kind of levels out because note the slope of the tangent line is more or less the same all throughout here. Until it starts getting here where it gets less and less negative. Right, so what I want is this thing in green to still have a negative height, just to be not as far down negative, and higher up until it goes through this point. And then the slopes of the tangent line in here, well, now it's a positive number, and it gets more and more positive until we get somewhere in here. So this is about as high as it gets. But note, it never gets all that steep. So I don't know, maybe something like that. Positive, but it's not that positive. I don't have a y-axis, so really that gives you the freedom to kind of make these things as high or as low as you want. I'm going to draw something like that. Then it hits this point, and it starts going down again. And it never goes down all that fast. There's somewhere in here where it's going down as fast as it'll ever go down. So to me, this thing would look, I don't know, something like this. And then it hits this point, turns around, and starts going up. And in fact, it starts going up really, really, really fast. Looks to me like this just keeps going up. So I'm going to leave this something like that. Not the prettiest thing in the world. Maybe if I sketch over it, I can make it a little smoother. Because typically these things end up being pretty smooth. Although without knowing the equation of these lines, we don't really know. But I'm going to leave my final answer looking something like this. So all that is just the graph of the derivative, which kind of checked one box. Unfortunately, there's still a few boxes left. The next box to check is you're supposed to graph the second derivative. You can graph the second derivative just by looking at this thing in red, but it's pretty hard to do. It's a lot easier to say that the second derivative is just the derivative of the derivative. And I just drew the derivative in green here. So if I completely ignore the red, I can draw the second derivative by just staring at this thing in green and trying my best to represent the slope of a tangent line to this thing in green. So much like I did when I was drawing the thing in green, I'm going to first focus on the zeros, this time the zeros of the second derivative. So somewhere in here, the thing in green kind of levels out. If I were to draw tangent lines to my first derivative, I would draw a horizontal line there, a horizontal line somewhere in here, and a horizontal line somewhere in here. So I better go through those points. And then let's see, the slope in here is negative. And it's quite negative. It's going down pretty steep, and then it becomes less and less and less and less negative until I get to right here where it flattens off. So my graph is going to look something like this, roughly speaking. Note that the height of this thing in blue is negative all the way from out here up to this point -1 because this thing is going down all the way until I get to -1. When it hits -1, it turns around and starts going up for a while. It goes up faster and faster and faster until I get somewhere in here, at which point it's still going up, it's just going up less and less fast. So my graph is going to look something like this. Note that this hump doesn't go up all that high because this thing in green never gets all that steep. It's all kind of subjective with no y-axis, but that's why I chose to draw that way. Then this thing continues. It's flat right here, so the height of the thing in blue better be 0. But then it starts going down, 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 faster and faster until somewhere around here where it turns around and gets flat here. So this thing better get further and further down until it gets to somewhere in there, that point where it stops getting steeper and starts kind of leveling off. And it levels off until it gets back to that point. And then everything that happens after that is not that interesting. It starts going up, and it does so faster and faster and faster and faster. So this thing is going to start going up and do so faster and faster and faster and faster. That thing in blue is an approximation of my second derivative, whereas this thing in green is an approximation of my first derivative. Okay, I'll leave you to add comments if you feel like it. Hopefully I spoke enough comments, because I got another problem to do. The second problem says that, okay, I know this looks like the same graph, but think about it totally differently. This thing in red is no longer the function f. Instead, it's the derivative of some function g. So essentially, what you're given here is the answer to up here, and you're asked what is the question. You're kind of working backwards. So what I want to do is I'm going to assume this is the derivative. This was drawn properly. And I want to draw the function from which this was drawn. I guess that's one way you can think about it. Turns out there's lots of different functions from which this could be the derivative. So I have to kind of anchor my function somewhere. And that's what this is saying. It's saying that thing you're about to draw, g, make sure it goes through this point, -3, 0. Start out right here. Okay, I can do that. Goes through this point. So what does it do? Well, first of all, where is it going at this point? Like, it's going up. Look, this thing's going up. No, it's actually horizontal right here. And the reason the thing in blue is going to be horizontal right here is because the height of the thing in red is 0 right here. And if the height of the thing in red is 0, that means the slope of the tangent line to the function, the thing in blue that I'm about to draw, should be 0. This should be horizontal. When I'm slightly to the right of this point, this thing now has a positive height, so this should be going up. When I'm slightly to the left of this point, this thing now has a negative height, so this thing should be decreasing. The point that I'm trying to make is this thing that I'm going to draw in blue should look something like this. It's challenging drawing it like that. And then what happens? Well, this thing is positive all the way until I get to -1. So this thing that I'm drawing right here in blue better be increasing all the way until I get to -1. It starts out increasing very slowly, and then it starts increasing faster and faster and faster and faster until it gets in right here. So this thing starts out increasing really slowly, but it starts increasing faster and faster and faster until I get to right here. And then it continues increasing, it just does so more and more and more slowly. So this thing is going to kind of look like this. The technical terms for those things that I just described, increasing faster and increasing more and more slowly, are concave up and concave down. We will later, I guess depending on when you watch this video, learn that, well, I'll get into concavity later. My graph looks like this. At 1, note that it levels off again. That's perfect. I wanted the height of this thing in red is 0 here, so the slope of the tangent line to my thing in blue right there better be horizontal, better be 0. So then what happens? This thing is now below the axis all the way until I get to 4. What that means is if my thing in blue starts increasing anywhere from here to here, I screwed up. It's below the axis, or I guess at best case it's 0. So that means this thing has to be going down, or maybe is flat all the way until I get to 4 here. How quickly is it going down? Well, right here it's not going down fast at all, because this height is just barely negative. But when we get over here, it's going down relatively fast. So this thing starts out going down, and it starts going down pretty slowly, but then it speeds up. It's going down faster and faster and faster until I get to right here. The thing in red turns back up here. The thing in blue is not going to turn back up because I don't want the thing in blue increasing, because the thing in red is not positive. Instead, I want the thing in blue to continue to decrease, just to do so more and more and more slowly. until you get to 2 when this thing levels off. Because the height in red here is 0, so the slope here should be 0, aka the tangent line should be horizontal. And then what happens? Well, it's just briefly flat here, right at 2. And then we're below the axis again. So we're below the axis all the way into 4, so this thing's got to keep decreasing. It starts out decreasing very slowly, but when it gets right here, it's decreasing a little bit quicker. So this thing kind of looks like this. And then I get to this point here, where it's decreasing as fast as it'll ever decrease. I want it to be flat by the time it gets to 4, so I'm going to kind of make it look like this. Once it hits 4, the slope is flat, and then it crosses up and it's positive. When the thing in red is above the axis, the slope of the tangent line to the thing in blue is positive. So what that means is finally my graph in blue is going to start increasing. And it looks like it increases faster and faster because the height of this thing gets higher and higher. Graph looks something like this. This is very approximate depending on how high up and how low you made this. Like, I have no idea that I crossed the axis right here at 1/2. You'll learn in calculus too how to figure out exactly where this crosses the axis. But for our purposes, if you drew this and you got it crossing the x-axis over here, that's just as correct. This is very, very much an estimation of what G would look like if this thing in red is G prime. But hopefully that's good enough to give you an idea of how to draw these. I think I will end this video here.